What is CRISPR technology? CRISPR is an acronym standing for Clustered, Regularly Interspaced Short Palindromic Repeats. To put it simply, CRISPR technology uses a process that bacteria in our bodies use to help fight against viruses. This bacteria uses a process that helps it detect foreign DNA that the viruses have injected, then cut away the bad DNA and replace it with good, non-viral DNA. Scientists have managed to hijack this process that the bacteria use and are now able to select DNA strands that are cut away and also what DNA will be replacing the old stuff. One of the common regularly proposed uses of CRISPR technology is to kill certain disease-carrying species of mosquitoes. We often don't see mosquitoes as a threat. However, they are responsible for more deaths than any other animal. For instance, sharks are only responsible for 10 human deaths per year. Snakes, responsible for roughly 50,000 deaths per year, and humans coming in the second most dangerous thing to humans at 475,000 deaths per year, with mosquitoes clocking in at a whopping 750,000 human deaths per year. One of the main things that makes mosquitoes so dangerous is their ability to spread deadly diseases such as Zika, yellow fever, dengue, and malaria. There have been many attempts to stop the spread of these diseases over the years. Using bug repellents containing DEET was a main deterrent for a long time. Over the years, we've also seen a wide adoption of bed nets that has proven to be a very good deterrent. However, the use of DEET has been banned in many countries due to environmental effects, and the use of bed nets at night have pushed these mosquitoes to adapt to a day hunting cycle. As a sort of last-ditch effort, scientists have proposed that we release genetically modified mosquitoes that have been modified using this CRISPR technology into the ecosystem. These mosquitoes have been modified with a recessive gene that will cause the future generations to be sterile, thus killing off large portions of the population. While there was a similar eradication back in the 1960s with the screwworm fly, it is difficult to tell how removing a species from the environment will affect the ecosystem. It is possible that animals like frogs, spiders, and bats rely on mosquitoes as a primary food source, leaving them with much less food post-eradication.
Thanks, Hayden. 3D printers have taken the world by storm in the last 5 years. With a format, material, and one incredible machine, we can print items as easily as we print a newspaper. From bowls to wheels, toys to spare parts, almost anything can be made. But there's one group that has taken it a step further and revolutionized the revolutionary: doctors. In recent years, medical researchers have developed a biodegradable plastic that, when combined with a patient's cells, can be used to 3D print organs. This technology could one day eliminate the need for organ donors.
Now here at Technology Tomorrow, we don't have access to a medical 3D printer, but we do have a standard 3D printer that can make a model of the human heart. Let's take a look at what's happening. Here you can see the printer laying down the base of the heart, layer by layer. In medicine, this would be a biodegradable plastic that would absorb into the human body over time. Now you may ask, how can a plastic be biodegradable? Well, there are many different kinds of plastics. The kind we use for Tupperware, the kind we use for car tires, etc. All plastics, however, are made of polymers. Polymers are repeating chains of hydrogen and carbon atoms, two of the main elements of the human body. So by using the right kind of polymer, we can create a plastic that the human body absorbs. Observe as the machine builds the heart. At this point, doctors would add a blend of the biodegradable plastic and the patient's cells. This is a slow process, but it is much easier than finding a donor. There are over 100,000 people in America waiting for an organ, but it can't be just any organ. To be a match, A donor must have the same blood type as the recipient, as well as similar antibodies. If a skin graft is needed, they must also be of a similar skin tone. It's like trying to find a twin or a brother from another mother. 20 people on the list die each day waiting for that match. And if they do find a match, they will be on immunosuppressants, drugs that stop the body from attacking the new organ for the rest of their lives. This means that they will be prone to infection and even death from infection. Something as simple as the common cold could kill someone on immunosuppressants because it stops the body from making white blood cells that would normally fight infection or foreign substances, like the new organ. As the printing completes, more cells would be added to the printed organ, and it would be allowed to culture for several days or even weeks. This allows the recipient cells and tissue to grow and combine with the plastic. After this process, the organ can be transplanted. The patient will not need to be put on a waiting list, nor will they need immunosuppressants. This custom-made organ will become a part of them for the rest of their lives. And now, over to Lexi.
Caring for those with brain tumors requires the use of highly specialized brain monitoring and neuroimaging equipment. This equipment guides the therapies used to rid the brain of diseased tissue without damaging healthy tissue. Many types of brain tumors used to be considered inoperable, but with the help of up-and-coming technology, this will change the outcome for thousands of people. Just to give a few of the leading technologies we have today. Neuroblate technology, which uses magnetic resonance imaging, MRI-guided lasers to destroy tumors without damaging the surrounding healthy tissue. This minimally invasive approach is especially effective in treating glioblastoma, one of the most aggressive and difficult to treat types of brain cancer. UH Cleveland Medical Center was among the first in the world to use and help come up with this technology and is still one of a limited number of hospitals in the United States that offer this service. CyberKnife, a painless, non-invasive robotic radiation technology that gives patients new hope for treatments of tumors and lesions previously considered untreatable or inoperable. Gamma knife radiosurgery, which delivers critical radiation to a precisely targeted area, sparing surrounding tissue. With this non-invasive procedure, the targeted tissue gets the highest dose of radiation. Intraoperative MRI operating suites, which allows hospital surgical teams to use MRI imaging to track surgical process in real time. The Brain Tumor and Neuro-Oncology Center built one of the world's first intraoperative MRI operating suites, which was the first of its kind in Ohio. The suite is mixed with other state-of-the-art techniques such as awake brain mapping of motor and language functions to have the safest possible surgery. Proton therapy. University Hospitals is the first in Ohio to offer proton therapy, an advanced radiation therapy technique that can precisely target tumors while sparing healthy tissue. This painless outpatient procedure allows patients to continue their normal everyday activities throughout treatment. It has the potential to lessen side effects from treatment and can reduce the risk of developing radiation-induced secondary cancers years after treatment is completed. With these different types of treatments today, many people who would have once died from their tumors are now being able to be helped and operated on with no issues due to today's technology and where we are going with it. We are making new medical discoveries for operating on brain tumors every year and When diagnosing cancer, you want to catch it as quick and early as possible. Many cancer types take time to diagnose and are sometimes found too late in the time span. This notion requires not only healthcare facilities and new diagnosing technologies, but also being positive to the patient. During cancer treatments, rebiopsies are needed many times. It means a new sample from the ever-changing tumor must be obtained to define the next step of therapy. With the current innovative biopsy techniques, this is a huge challenge not only for the patients but for the caregivers. An intelligent surgical knife was developed by Zoltan of Imperial College of London and works by using old technology where an electrical current heats tissue to make incisions with minimal blood loss. But with the surgical knife, the vaporized smoke is analyzed by a mass spectrometer to detect the chemicals in the biological sample. This allows real-time identification of malignant tumors. Surgeons will love this surgical knife that can significantly reduce the length of operations in oncology. In the case of AIDS, combining drugs with difficult targets resulted in the treatment that finally put a dent in the disease. Research shows the same applies to the cancer. By combining the increasing number of cancer therapies has so far proven difficult to the sheer number of possible combinations. New approaches in the field of system biology that uses computer models to predict therapy effects are promising to cut through this complexity and deliver effective combinational therapies in the coming years. Different approaches like immunotherapies put a focus on making a person's immune system sensitive to cancer cells, this way letting the immune system fight back. Most cancer treatments today do not destroy only cancerous cells, but also healthy ones. The ultimate goal is delivering drugs only to cancer cells that need to be treated. Using DNA cages holding a payload of drugs might be the answer. This method could be used in clinical trials soon as well. Cancer cells can trigger the DNA cage to open, and the drug can only make an impact in those cells, but not the healthy ones. The diagnosis of cancer is a huge event in someone's life. There's a reason cancer patients consider their life after to be the new normal. Although patients meet with their caregivers in person many times, they are often left to deal with the continuous pain and powerful side effects for the rest of their life. New technologies could help improve their experience forever.
Hey guys, today we're going to talk about some new technologies in medicine. Primarily, we're going to talk about robotic surgery. It's similar to virtual reality, except in the medical field, virtual reality is primarily used for training. In 10 years, robotic surgery will be in every hospital because of its versatility, its few complications, less blood loss, quicker recovery of the patient, etc. Robotic surgery is a minimally invasive surgery, which means it performs surgeries with small incisions rather than large. The surgeon behind the robot controls it by looking at a 3D image of the surgical site through a computer. He uses his fingers in the master controls, which reduces the fatigue of the surgeon, therefore reduces the length of the surgery. With the success of robotic surgery, many doctors and scientists speculate that in 10 years it can be used for open heart surgery, orthopedic, plastic surgery, etc. And it can be used with not only minimally invasive, but other surgeries too. Thank you all for watching.
Thanks, Luke. In this portion of Tech Tomorrow, I will be discussing eye transplants. Although eye transplants aren't available in the world yet, it would be a huge step forward in the medical field because there are more than 1 million Americans that are completely blind. The eye's complex web of muscles, blood vessels, and nerves connected directly to the brain has failed past experiments. The closest thing available today is a cornea transplant. The cornea is the clear lens on the front of the eye. During the cornea transplant, the lens is removed and replaced with donor tissue. Unfortunately, cornea transplants don't help with all vision loss, whereas a complete eye transplant could. Complete eye transplants are extremely complicated because the eye is connected to the brain through the optic nerve. Once the optic nerve is cut, it is difficult to keep the eye alive. Surgeons estimate that it will be several years before it is safe enough to test on a human. A reconstructive and transplant surgeon at the University of Pittsburgh has conducted several eye transplants on rats. On one rat, he was able to keep the eye alive for 200 days. Unfortunately, he did not do a behavior test to see if the rat could actually see, instead focusing on keeping the eye alive. The next step in experimentation is going to be the eye transplants on pigs. Pigs' eyes are 20% smaller than a human eye. That means that the vessels are very similar to humans. So again, the biggest challenge surgeons face is keeping the eye alive long enough to get it reattached. The eye can only survive without blood supply for 2 to 4 hours. Also, once the optic nerve is reconnected, it is hard to get the nerve cell to regrow. Therefore, the next big experiment is to accomplish will be transplanting a whole eye onto an animal and show nerve regrowth from the donor's eye to the recipient's optic nerve. We have a long way to go before being able to try eye transplant on a human. But we have also come a long way in the past couple of years. After the research I have done, I think we will be performing our first human eye transplant on a completely blind person in the next 5 to 6 years. And now, over to Caleb.
Lastly in this episode, we're going to take a look at virtual reality in medicine. But first, let's go back and take a look at virtual reality's early beginnings. It first started in about 1929 when Edward Link created one of the first ever commercial flight simulators. They were completely electromechanical, and a small motor emulated turbulence and disturbances that you would actually experience in real flight. During the Second World War, these simulators trained over 500,000 pilots to improve their flying technique. During the 1930s, a science fiction writer, Stanley G. Weinbaum, came up with the idea of a person wearing a set of goggles to experience a fictional world that had taste, touch, and smell. These goggles, also called the Pygmalion Spectacles, are almost identical to the VR headsets that we see today. Fast forward to about the 1990s, and we see some virtual reality devices in arcades, in video games, but still not commercially available to the public. In about 1993, Sega announced their Sega VR headset to go along with its Sega Genesis console. Although Sega had plans to release their headset with the price of $200, it was plagued with technical difficulties and had to remain on the back shelf. Nintendo had the same idea in about 1995 when it came out with the Nintendo Virtual Boy, but it had similar difficulty when it released due to the lack of color graphics and software support for the console. Fast forward to the 21st century, and virtual reality has seen a resurgence with the rapid advancement of technology. The video game industry has been on the forefront to bring virtual reality to the public, with such devices as Oculus Rift, PlayStation VR, and many others. Although virtual reality has stayed much in the realm of video games, many other companies and organizations are seeing the benefits of VR, especially in the medical field. Many medical VR programs such as augmented vision surgery, remote treatment, and distance diagnosis are now becoming commonplace. Many new and innovative practices are being developed and engineered specifically in Singapore to provide non-invasive safe outcomes. One large organization, which is IMDA, is partnering with designers at SEAP, which stands for Side Effects of Asia Pacific, and their focus is to create VR tech that advances clinical training. This is because students can learn at a pace that is comfortable for them. And this technology could simulate many scenarios such as a mass vehicle accident where trainees are dealing with many problems that need quick and acute responses. This new VR approach has multiple benefits for being cost effective, it's safe, and it's the closest possible program to simulate real clinical procedures. This is fantastic because it allows basic and difficult skills to be practiced repeatedly for real live surgery. Virtual reality is growing rapidly in the medical market, and analysts project the VR and AR healthcare market will reach $5.1 billion by 2025. Many medical schools already are adding virtual and augmented reality centers to their campuses, and one example of this is the University of Nebraska's Medical Center spent $118.9 million on their VR center, which they hope will change healthcare education similar to how the aviation simulation changed the flight industry. Medical VR is rapidly growing, and without a doubt, in the next 10 years, we are sure to see medical VR facilities all over hospitals and campuses. Thanks for watching this episode of Technology in Tomorrow. Hopefully we'll see you next time in our next video.